All electric vehicles, also referred to as battery electric vehicles, BEVs, use a battery pack to store the electrical energy that powers the motor. The batteries are charged by plugging the vehicle into an electric power source. Although electricity production may contribute to air pollution, the U.S. Environmental Protection Agency categorizes all electric vehicles as zero-emission vehicles because they produce no direct exhaust or tailpipe emissions locally. Both heavy-duty and light-duty all-electric vehicles are commercially available. BEVs are typically more expensive than similar conventional and hybrid vehicles, although some cost can be recovered through fuel savings, a federal tax credit, or state incentives. Today's all-electric vehicles generally have a shorter range, per charge, than comparable conventional vehicles have, per tank of gas. However, the increasing range of new models, using higher energy batteries, and the continued development of high-powered charging equipment is reducing this gap. The efficiency and driving range of BEVs varies substantially based on driving conditions. Extreme outside temperatures tend to reduce range, because more energy must be used to heat or cool the cabin. All electric vehicles are more efficient under city driving than highway travel. City driving conditions have more frequent stops, which maximize the benefits of regenerative braking, while highway travel typically requires more energy to overcome the increased drag at higher speeds. Compared with gradual acceleration, rapid acceleration reduces vehicle range. Hauling heavy loads or driving up significant inclines also has the potential to reduce range. An electric car or electric vehicle, EV, is a passenger automobile that is propelled by an electric traction motor, using only energy stored in onboard batteries. Compared to conventional internal combustion engine, ICE, vehicles, electric cars are quieter, more responsive, have superior energy conversion efficiency and no exhaust emissions and lower overall vehicle emissions. However, the power plant supplying the electricity might generate its own emissions. The term electric car normally refers to battery electric vehicle, BEV, but broadly may also include plug-in hybrid electric vehicle, PHEV, range extended electric vehicle, REEV, and fuel cell electric vehicle, FCEV. The electric vehicle battery typically needs to be plugged into a mains electricity power supply for recharging in order to maximize the cruising range. Recharging an electric car can be done at a variety of charging stations. These charging stations can be installed in private homes, parking garages, and public areas. There are also research and development in other technologies such as battery swapping and inductive charging. As the recharging infrastructures, especially those with fast chargers, are still in its relative infancy, range anxiety and time cost are frequent psychological obstacles against electric cars during consumer purchasing decisions. Worldwide, 10 million plug-in electric cars were sold in 2022, a total of 14% of new car sales, up from 9% in 2021. Many countries have established government incentives for plug-in electric vehicles, tax credits, subsidies, and other non-monetary incentives, while several countries have legislated to phase out sales of fossil fuel cars, to reduce air pollution and limit climate change. EVs are expected to account for nearly 1/5 of global car sales in 2023, according to the International Energy Agency, IEA. China currently has the largest stock of electric vehicles in the world, with cumulative sales of 5.5 million units through December 2020, although these figures also include heavy-duty commercial vehicles such as buses, garbage trucks, and sanitation vehicles, and only accounts for vehicles manufactured in China. In the United States and the European Union, as of 2020, the total cost of ownership of recent electric vehicles is cheaper than that of equivalent ICE cars, due to lower fueling and maintenance costs. In 2023, the Tesla Model Y became the world's best-selling car. The Tesla Model 3 became the world's all-time best-selling electric car in early 2020, and in June 2021 became the first electric car to pass 1 million global sales. Together with other emerging automotive technologies such as autonomous driving, connected vehicles, and shared mobility, electric cars form a future mobility vision called autonomous, connected, electric and shared, ACEs, mobility. The term electric car typically refers specifically to battery electric vehicles, BEVs, or all-electric cars, a type of electric vehicle, EV, that has an onboard rechargeable battery pack that can be plugged in and charged from the electric grid, and the electricity stored on the vehicle is the only energy source that provide propulsion for the wheels. The term generally refers to highway-capable automobiles, but there are also low-speed electric vehicles with limitations in terms of weight, power, and maximum speed that are allowed to travel on public roads. The latter are classified as neighborhood electric vehicles, NEVs, in the United States, and as electric motorized quadricycles in Europe. Robert Anderson is often credited with inventing the first electric car sometime between 1832 and 1839. The following experimental electric cars appeared during the 1880s. In 1881, Gustave Trouvé presented an electric car driven by an improved Siemens motor at the Exposition Internationale d'Électricité de Paris. In 1882, Werner von Siemens presented the world's first trolleybus in Berlin. In 1884, over 20 years before the Ford Model T, Thomas Parker built an electric car in Wolverhampton using his own specially designed high-capacity rechargeable batteries, although the only documentation is a photograph from 1895. In 1888, the German Andreas Flocken designed the Flocken Elektrowagen, regarded by some as the first real electric car. Electricity was among the preferred methods for automobile propulsion in the late 19th and early 20th centuries, providing a level of comfort and an ease of operation that could not be achieved by the gasoline-driven cars of the time. The electric vehicle fleet peaked at approximately 30,000 vehicles at the turn of the 20th century. In 1897, electric cars first found commercial use as taxis in Britain and in the United States. In London, Walter Berzy's electric cabs were the first self-propelled vehicles for hire at a time when cabs were horse-drawn. In New York City, a fleet of 12 hansom cabs and one brougham, based on the design of the Electrobat II, formed part of a project funded in part by the Electric Storage Battery Company of Philadelphia. During the 20th century, the main manufacturers of electric vehicles in the United States included Anthony Electric, Baker, Columbia, Anderson, Edison, Riker, Milburn, Bailey Electric, and Detroit Electric. Their electric vehicles were quieter than gasoline-powered ones, and did not require gear changes. 6 electric cars held the land speed record in the 19th century. The last of them was the rocket-shaped La Jamais Contente, driven by Camille Janazzi, which broke the 100 km/h 62 mph speed barrier by reaching a top speed of 105.88 km/h 65.79 mph in 1899. Electric cars remained popular until advances in internal combustion engine, ICE, cars and mass production of cheaper gasoline and diesel-powered vehicles led to a decline. ICE cars' much quicker refueling times and cheaper production costs made them more popular. However, a decisive moment came with the introduction in 1912 of the electric starter motor that replaced other, often laborious, methods of starting the ICE, such as hand cranking. In the early 1990s, the California Air Resources Board, CARB, began a push for more fuel-efficient, lower-emissions vehicles, with the ultimate goal of a move to zero-emissions vehicles such as electric vehicles. In response, automakers developed electric models. These early cars were eventually withdrawn from the U.S. market, because of a massive campaign by the U.S. automakers to discredit the idea of electric cars. California electric automaker Tesla Motors began development in 2004 of what would become the Tesla Roadster, first delivered to customers in 2008. The Roadster was the first highway-legal all-electric car to use lithium-ion battery cells, and the first production all-electric car to travel more than 320 kilometers, 200 miles, per charge. The most expensive part of an electric car is its battery. When designing an electric vehicle, manufacturers may find that for low production, converting existing platforms may be cheaper, as development cost is lower. However, for higher production, a dedicated platform may be preferred to optimize design and cost. Electric cars have several benefits when replacing ICE cars, including a significant reduction of local air pollution, as they do not emit exhaust pollutants such as volatile organic compounds, hydrocarbons, carbon monoxide, ozone, lead, and various oxides of nitrogen. Similar to ICE vehicles, electric cars emit particulates from tire and brake wear which may damage health, although regenerative braking in electric cars means less brake dust. More research is needed on non-exhaust particulates. The sourcing of fossil fuels, oil well to gasoline tank, causes further damage as well as use of resources during the extraction and refinement processes. Depending on the production process and the source of the electricity to charge the vehicle, emissions may be partly shifted from cities to the plants that generate electricity and produce the car as well as to the transportation of material. The amount of carbon dioxide emitted depends on the emissions of the electricity source and the efficiency of the vehicle. For electricity from the grid, the life cycle emissions vary depending on the proportion of coal-fired power, but are always less than ICE cars. The cost of installing charging infrastructure has been estimated to be repaid by health cost savings in less than 3 years. According to a 2020 study, balancing lithium supply and demand for the rest of the century will require good recycling systems, vehicle-to-grid integration, and lower lithium intensity of transportation. Some activists and journalists have raised concerns over the perceived lack of impact of electric cars in solving the climate change crisis compared to other, less popularized methods. These concerns have largely centered around the existence of less carbon-intensive and more efficient forms of transportation such as active mobility, mass transit, and e-scooters, and the continuation of a system designed for cars first. Internal combustion engines have thermodynamic limits on efficiency, expressed as a fraction of energy used to propel the vehicle compared to energy produced by burning fuel. Gasoline engines effectively use only 15% of the fuel energy content to move the vehicle or to power accessories. Diesel engines can reach onboard efficiency of 20%. Electric vehicles convert over 77% of the electrical energy from the grid to power at the wheels. Electric motors are more efficient than internal combustion engines in converting stored energy into driving a vehicle. However, they are not equally efficient at all speeds. To allow for this, some cars with dual electric motors have one electric motor with a gear optimized for city speeds and the second electric motor with a gear optimized for highway speeds. The electronics select the motor that has the best efficiency for the current speed and acceleration. Regenerative braking, which is most common in electric vehicles, can recover as much as 1/5 of the energy normally lost during braking. Lithium-ion-based batteries are often used for their high power and energy density. Batteries with different chemical compositions are becoming more widely used, such as lithium iron phosphate, which is not dependent on nickel and cobalt, so can be used to make cheaper batteries and thus cheaper cars. The range of an electric car depends on the number and type of batteries used, and, as with all vehicles, the aerodynamics, weight and type of vehicle, performance requirements, and the weather. Cars marketed for mainly city use are often manufactured with a short-range battery to keep them small and light. Most electric cars are fitted with a display of the expected range. This may take into account how the vehicle is being used and what the battery is powering. However, since factors can vary over the route, the estimate can vary from the actual range. The display allows the driver to make informed choices about driving speed and whether to stop at a charging point en route. Some roadside assistance organizations offer charge trucks to recharge electric cars in case of emergency. Most electric cars use a wired connection to supply electricity for recharging. Electric vehicle charging plugs are not universal throughout the world. However, vehicles using one type of plug are generally able to charge at other types of charging stations through the use of plug adapters. Electric cars are usually charged overnight from a home charging station, sometimes known as a charging point, wall box charger, or simply a charger, in a garage or on the outside of a house. Public charging stations are almost always faster than home chargers, with many supplying direct current to avoid the bottleneck of going through the car's AC to DC converter, as of 2021 the fastest being 350 kilowatts. Thank you for watching this video.